Now, the last big meteor shower of the year peaks this weekend. The Geminids are expected to light up the sky tomorrow and on Sunday. And if the weather cooperates, it should be a pretty spectacular show. For more, we've reached Phil Langill. He's a professor of physics and astronomy at the University of Calgary. So why does everyone get so jazzed about this particular meteor shower? What makes the Geminids so cool?
Well, every meteor shower is cool. I mean, that's the great thing about it. They're very unpredictable. Now, I just want to put a little disclaimer out there that what we're trying to do here is predict the weather. And you know how weather people hit and miss sometimes. We know roughly the time that this event should happen, but as far as how many meteors and how bright they're going to be and all that kind of stuff, it's really hard to say.
Yeah. I know sometimes as a metaphor, we say the planets have to line up, but that's just about your field anyway. So
Right.
what are we actually seeing in the sky during a meteor shower? What's the science?
Yeah, okay, so they're commonly called shooting stars, right? Meteors are shooting stars. So they kind of look like stars that are dropping out of the sky. So it's kind of an apropos little metaphor there. But what is actually happening is where the Earth is traveling through space as it makes its way around the sun. And at this time of the year, there's a debris field of little bits of dirt and sandy bits, and we slam into it. And because the speeds are so high, many tens of kilometers per second, they hit the atmosphere and they just get destroyed by the heat that happens. It's just friction, and then they start to glow. They light up, and we see that from the ground as a streak of light across the sky.
So they're burning up, then they're gone?
Yep. Well, I mean, the little ones will burn up for sure. The larger ones, which are very rare, I mean, if you think about what's common, the big ones are very uncommon, and the teeny tiny ones are super common. So if they're big enough, they can survive the journey through the atmosphere and make their way down to the ground. But that's pretty rare.
What what map out size for us? Like what's a teeny tiny one?
They have to be big enough to be bright enough to burn long enough for the human eye to see. And those ones I imagine are like the size of your fingernail on the tip of your finger.
Okay.
That's the size. But there are many smaller ones than that they do burn up, and if it's really dark out where you are and your eyes are super dark adapted and all the variables are in your favor, you can see quite a few of those fainter ones. But you have to be searching for dark skies to see those faint ones.
Right. Is there meteor interaction with the moon?
Well, yeah, there is. Of course, this debris field that we're going through is huge in size, and it certainly is as big as the whole Earth and as big as the whole Earth-Moon system. So if you were on the moon, you wouldn't see a streak because there's no atmosphere and nothing would burn up, but you would be pelted by little teeny tiny bits of sand hitting you at about 10 kilometers or 20 kilometers per second. It wouldn't be fun, but they're very small. There is the astronauts that went to the moon and brought back moon rock samples. The first thing that people noticed was these rocks were covered in little impact craters, little divots. And when they compare them to Earth rocks don't have these divots at all. And so that just speaks to the fact that the moon over the eons has been pelted by these little bits of debris that's all over the solar system. And Earth rocks don't experience that because the atmosphere protects them, and all that stuff burns up. So it's a real fundamental difference between moon rocks and Earth rocks.
Sure does make you appreciate our atmosphere, Phil.
Indeed, it does. And if you like to breathe, it's a good thing too.
Right. Well, I do. Now, if the weather cooperates, what should people expect? Like how many meteoroids or shooting stars might a person be able to count in an hour, say?
Oh man, like you put me on the spot because, like I say, it's really hard to predict that kind of thing. I would say, historically, based on historical information, if you're in a super dark place, and by the way, if it's cloudy, if you can't see the stars, you're not going to see the meteors.
Right.
So you have to have conditions where the stars are out, and it's best to be away from the light pollution of the city. So you want to get to a darker place, and oftentimes the elephant in the room, to use that expression, is the darn moon. The moon actually, when it's bright, like when it's full, it splashes light all across the sky, and it makes it really hard to see these very faint meteors streaks going across the sky. But the moon is actually cooperating. The moon is just a thin crescent, and it rises quite late in the evening. And so the moon isn't going to be a problem. So the potential is for a really good show if you can get to a dark place. And I'm going to say, depending on your eyesight, because different, people have different eyesights. I'm an old guy, so my eyes aren't as good as they used to be. Maybe I'm going to say 20 or 30 in a half an hour or something like that. Maybe one a minute, one every couple of minutes, something like that.